downtown Mill Bay. N2. Pardon?
Anyway, we can just leave it off to the quiz today.
Zombie apocalypse? And as we're doing that, let's do some attendance. We are block C. Anders?
Yeah.
Hayden?
Yep.
Esther?
Yeah.
Hillary? Jennifer? Jennifer? There you are. Jojo?
Yeah.
Julian Chan?
Here.
Julian Gigi?
Here.
Liam?
Here.
Lucas? Mirhat? Mick? Oliver? Pablo? Riley? Vienna? Zach?
Here.
Those of you sitting down, have you drawn your version of N2 up there?
Yes.
Excellent. And we're live. And, oop, there we go. We are C. Bootmaker 2. Excellent.
So funny.
You have too many electrons. So if you're going to do that method, we can start up with the valence structure. So how many electrons? They keep your desk set up. They keep taking my racers, like carefully putting all over the the reason being the oil.
I like you when somebody said
There you go. Now,
yeah, like,
well, that's 4 electrons. Now you have a 4 electron bond. Bonds often have only 2 atoms. Put those 2 back. Yeah. How many electrons does nitrogen now think it has? Yeah, 2.
I don't, we just.
that's why you need to do the triple bonds of each of those pieces.
You have a 1, 2, 3, 4.
No, you have to have 8 on one. Not all together. You have to have 16 altogether. So you charge is -1. So 1, 2, 3, 4, 5, 6. Yeah, it's not going. That's 24.
So smart.
Boom. Good. 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 Good.
You got it.
Something happened. Something happened, but started off well. Okay, it is a triple bond, very stable molecule. Most explosions end with nitrogen gas because it is so stable. And one of the great discoveries of the 20th century was how to take nitrogen from the air and turn it back into something like fertilizer. The person who did that has probably saved more human lives than any other person in history because fertilizer is what feeds the world. At the same time, he was also at the time considered a war criminal and generally disliked because if you can turn nitrogen in the air, which is this, into something else, you can not only make fertilizer, you can also make bombs. So it's a bit of a double-edged sword. So the triple bonds are good. Now this has the right number of electrons, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, so the right number of electrons. However, what check do you need to do to see whether or not you should stop? Yep.
See if all of them have 8.
See if all of them have 8. What's the magic term for seeing if all of them have 8? No, someone else. I don't know. Someone else? It is counting. The magic term for it. It's a rule, octet. So we have the octet rule. So always double check. We've got that. So this isn't happy, but you have the right number of electrons. You need to just start adding electrons, which is good. So when you don't have an octet, that's when you start making a double bond. So those go away and they become a bond. Now without those, it has 2, 4, 6, 2, 4, 6, 8. One of them's happy, but the other one isn't. Well, if this one's happy, then it could share what it has with what one that doesn't have it. And that could also go in there, and now they're happy. 2, 4, 6, and then 8 and 8, so that one thinks it has 8, 2, 4, 6, 8. This one has 2, 4, 6, 8, and so now they think they're similar with this one. If that's the same as that one, you just need to bring them in to create more bonds. So the Lewis dot diagram method of doing it, you make the Lewis diagram, it's got 5 valence electrons. A bond is 2 electrons, so you start joining up the unpaired ones. And you can see that nitrogen will be triple bond all the way. If you're using the other method, which has turned out to be useful at times, you take the nitrogen, put them in, bond them once, -2 electrons, we've got 8. Then you give them all to the one that's not the central atom, which I will artificially say is this one. But I can't give all 8. Why? I have to stop at 6. Yeah.
Because it's already taking 2 from the bond.
It's already taken 2 for the bond, so I have to stop at 8. So I minus my 6. I got 2 electrons left over. You take whatever you have left over, and you put it on the central atom. And then you realize this one's profoundly unhappy. So you start adding bonds until it's fine. 2, 4, 6, 8. And we end up with the same structure. Are you guys working on the next one? Excellent. Now we're going to do NO3. -1. However, grab your partner. Who is that person? Caden, you can join any group you'd like. Grab your partner. Erase what's on the board. Try it again.
Which one? Next question?
Yeah.
Yep. The NO3 minus. I'll put it back up.
Oh, shoot.
What?
No, I just wondered what group I was in.
Everybody know what group they're in? Julian?
Yeah.
Is your name not up here? Oh, there it is. You got your partner? Okay. Okay, NO3.
Oh, hello.
Ooh. Miss Stewart is back. While you're working at that, I'm going to go and ask if we're allowed to use the fume. once you think you have the right structure, you can have a seat. A reminder, what is the final check that you should do?
Okay. So basically, well, and I can tell you what you have. The goal is you want to make all of them equal scale. Because, but there's not enough left to give everyone eight, so they do things share. So first, I choose here. I come six of them. That's fun. You want to do like all of them also. So basically, can you do these? See, this one is the A.
Ooh, clever. If any of you are making rings, there are no rings. There's a central atom. Outer atoms are only connected to the central atom. We restrict ourselves to those possibilities to make the questions easier. No rings.
Share number two. Share here. I might just, I get this one only is five, right?
Wait, so 1, 2, 3, 4, 5, 6. So
That was six. You bond all of these together. All of it, you bond all of these together. So you can do that's kind of cool.
I was bonding them all separately.
I think that I don't know if that's how we're supposed to do it. It does sound a lot easier.
If you think you got it, see, a lot of good work. Good guessing. Remember, your final check is the octet rule.
So we didn't do like the.
And you need the right number of total electrons.
New for this question over here, do we bond them all together or separately?
Oh no, they're each one's a separate
Oh,
compound.
thank God.
They must all be together.
I was about to be scared.
Yeah.
What has you done to us?
Yeah.
We did this. How long? When did we do this?
Last day?
Yeah.
I wasn't here.
Yeah.
So I don't really know what's going on.
Okay.
Like it was like all
Uh,
Yeah,
Listen and watch, but that's tutorial. Get the notes from your friend. Watch the live stream. I expect you to come to class having already reviewed it with questions. If you're away, you can't come to class and say I want all of last day's lesson now. But I'm going over all the rules every single time. So yes, you will get it. But do you know what the number of valence electrons are? You know what the number of valence electrons are? That's from even before that. The valence electrons are the outermost electrons. So how do you quickly tell the number of valence electrons in an element off the periodic table?
Okay. Seal has
Pull out your period table. And your notes.
some.
You have nothing in front of you.
Some.
Pull out your notes, get out your binder, put your bag on the floor. Sir, you can't just borrow one, you can have
Can
one.
I have a periodic table as well?
Yeah.
Oh.
Okay, come on.
Why?
Should I
Who
go
needs a
to
periodic table? How good is it already? On the other hand, you were working so hard, you needed another one. Anybody else need one? You need one? Okay. The periodic table minutes, the structure. So, if I ask you for the number of valence electrons, or I ask you for electron structure of magnesium, for example, it would be 1, 2 in the first shell, 1, 2, 3, 4, 5, 6, 7, 8 in the second shell. And then 1, 2, 3, 4, 5, 6, 7, 8.
You need SOG?
Yes, that'd be.
I've not done that one.
If I ask you for the electronic structure of magnesium,
Mine.
goes in a 2, 8, 8,
I think the sulfur works the same as the
right?
Oh,
so on top of it, like she's paying so much attention, and they'll be like really impressed.
So you can just count along the number of electrons in each shell.
A few, and sometimes there's vibrating.
That's the total number, but that's not the number in each shell. Right, you guys have your piece of paper?
Does work.
Almost everyone else gave nitrogen, no.
That's true. And then like, well,
I think that's how it works. Does that make sense to you? 24 electrons total.
and then when they look at hydrogen, they'll be like, oh my god,
The only exception is if you were in hydrogen.
except it's plus, except it's
Okay.
-1.
Feel the noble gases.
If I can get your attention, do we go along? This was a great start. Is oxygen happy?
No. Yes. Oh, I
2,
didn't see that
4,
one.
6, 8. 2, 4, 6. That one's missing one. I think it's missing it. Oh, hold it. So you might have forgotten to account for something. So we're missing one there. Is that one happy? Yeah. Is nitrogen happy?
No.
No, nitrogen happy. So 2 of them are happy. Not quite there. Is oxygen happy in this one? Yeah. What's nitrogen doing? Hanging on 12, screaming in pain. You've shoved extra electrons at it. It's got 2, 4, 6, 8,
12.
10, 12. No, it is too much. So that one, instinct was right. You just went a little too far. This one, they all look happy, and the oxygen isn't missing an electron. So they accounted for something in here. If you have NO3 minus 1, what did they account for? The minus 1. The minus 1, what does that mean?
Plus.
Extra electron. So if you're doing this kind of model, you have to add an extra electron somewhere that makes sense. Or just save it and then put it in where you need it. So they added their extra electrons, so they started off with 24. So they did the accounting method. The accounting method does that quite well. Once again, too far, way too far, screaming in pain. Good instincts though, and did account for the extra electron. And excellent. No longer, well, actually, 2, 4, 6, 8, 9, screaming in a little bit of pain. And now none of the, well, that oxygen, no, none of the oxygens are happy. None of the oxygens are happy. But I'll show you how to fix that. So, I would say, compared to this, the instinct was good, it's just knowing when to stop. How do you know when to stop? When it's valence shell is full. I'm willing to bet that when you had this, let's take in that minus 1. We'll put in that extra electron here. And we're good to go. Willing to bet that when you started out, you went like that. Oops. Just, come on. That was a good idea. And then it was such a good idea, you were like, I'm going to do that again. And when you did it again, that's when it became a bad idea. Here, oxygen's happy. Is nitrogen happy? Yeah. Oxygen's happy. Oxygen happy. So the key was you only had to do it once. And you were just so excited you did it more than once. So don't forget the charge. And don't forget that every time you add a bond, stop and check. Is the outer atom still happy? Is the inner atom still happy? And then you can go on to the next one if it isn't. Because if nitrogen wasn't happy, then yeah, go to the next one. And you can keep going around. I'll put a version of that on the board. However, let's new groups. And then what I would like you to do is erase what's there. I want you to do all 4 of these. All 4. So, yeah, you need the group. Find your people. Do you have the?
Oh, you do this on the board?
Yeah. Do you have your board model or facility? I did, so I was gonna check it. But why don't you do this now? Go with your partner, work on that, and then we'll come back to that. Yeah. A what? Yeah. Yeah. It's their version of the Omnicom.
We're kind of lost on SO4.
SO4? It's the same as oxygen.
Steve, Mr. Griffo, can you please put up the...
Okay, everybody got it?
There is no SO3.
Take your...
CCL4, OF2, SO3, and O3.
That's what I know. How to know that. So,
You also have them on your pieces of
that
paper?
counts.
Because I'm going to go back in a second and write the old ones.
Sounds right.
I think I have some. How's 7? How's 7?
7? Okay.
7 times 4 is what? 28?
No, carbon 6. 4.
Yeah, but then 7 times 4.
No charge. Sweet. Excellent. Oh, what color? Oh, it's not 4. Oxygen is 6.
So we need 6. Yeah, we got 18.
No, chlorine doesn't have 6. Chlorine has 7.
Chlorine has 7.
Let's move those electrons around to make it easier.
SO3. Sulfur.
Silver is 6 too.
Let's.
Yeah, it does.
Okay, so 24 is also.
For 6 for me, at least 1
They can be divided by 4 can be divided by 6. Why do you want to divide? I don't know. I don't know.
Me, it should equal to 6. Oh, 6.
This one has 2 here.
Every oxygen has 8
And this one needs 6. So 1, 2, 3, and then
Oh,
18 plus 5 is 3.
each O is 6.
So are we just writing all the valence electrons for the Z bonding?
That's one way of doing it. Yep. If you put the valence electrons on each of them, you can bond it. Or you can do the accounting method where you count the total number of electrons and then put a central atom with the outer atoms, bond them, minus the electrons, so you see how many you have left. Put those in the outer ones until they have an octet, or until you run out of electrons.
I think this one's easier.
This one's easier than.
counting.
Oh, for this one, counting's way easier. Yeah, accounting works because when you do this one, you all of a sudden realize you have to move electrons around. But this one's really easy for ones like the CCl4 that's up there. It's easy for ones where you just join it, it works out perfectly. If it doesn't work out perfectly, then this one becomes easier. Yeah. Because at this point, when you do it this way, you go, oh, all the electrons are now, I just need to take that and put it in there, and you're done. Whereas in that one, you had to fiddle more. So, yeah, I like this method, but it's sometimes hard for people to see it, unlike the other method, where it can be really obvious. Because when we did ones like HCl, it's super easy to see when you do just the joining. Yeah. For some of these, I'd highly recommend you count your electrons. Make sure you have the right total number. Some people have invented electrons, I think. Electrons have come as if from nowhere. But once you're done, you can have a seat.
Are we ever gonna have like 3 atoms in one? Like a CCl or anything?
Yeah, you could. You just put a central atom down, put them all around it.
Are you gonna do that to us?
I could.
Fine.
Yes. Oh, I'm going to check it. But now just
Why
go
do
to
you
the
guys
next one.
add it?
Yeah. All 4 of them.
This one should have
It's a double bond.
2 more electrons.
I think it's, I'm hoping it's just symptoms. So I think we're good.
First things first, I would just make it a line. Doesn't really matter. I'll just show you how it goes.
I don't think so.
Yeah, we did.
No?
Look how many electrons fluorine has. No, on that.
How you guys doing?
Double bond is
Share a total of 4. So, 2 of each, right? Yeah. And this one gives another 2.
No, I'll let you know. So
Let's kind of take for you.
It just means here. It's why does it way too many. For counting them here, we go 1, 2, just skip everything in here. 3, 4, 5, 6, 7. Yeah, they don't do anything. So chlorine has how much? You just count? Yeah, just count. It's not true. 7. How many does chlorine have? 7. And bromine also has 7. We don't count either. Yeah, we only count these ones if you're here. So like titanium has 4, but
How'd it go?
Oh, you're from Korea?
Yeah, do you understand it?
I understand it, but it's just like complicated.
Did you make the data book?
Yeah.
Okay, yeah, you can notice it. It's just to the bottom.
I just noticed that now.
I just noticed that now.
Yeah, but I didn't make it now.
Yeah, yeah, no, but
I made it in the future.
yeah, it can
Because we
be.
were revising it.
It can be tell. You can tell it's been made by you. Yes, you can. One word. Or actually, one hand gesture. And
But,
where else?
but then hold it, but where did that come from? Not me, that's Mr. Snow. Joint task force.
Oh,
No, I see. No, I just did
Since, hey, Mr. Nuno, since you made it in the future, joint task force with yourself. Clones of yourself.
That would be good.
Yeah, I don't know.
say 10, 12, 16.
I was actually pops.
Which part? Okay, I'm actually glad that we had that session, bro. So now it's 10. So I thought, like, you guys,
So for SO3, sulfur has 6 valence electrons and so
are you ready?
so altogether 6, 12,
You're saying like
24 electrons total. So then you all have to ion them. So like 1, 2, 3, 3 bonds. And then you have to minus 6. And then you're left with 18 to put into your valence shells. Well, then that doesn't work because so you need to make an extra bond.
What, if you put that in?
Because if I was to put, for example, if I was to put these 18 on and try to get these all, I would end up with 22. So in order to combat that, I think another
Oh,
bond.
yeah.
Minus 2 of those, I end up with 18. And then I end up with 16 on the outer shell minus 2. Does that make sense? I can re-explain it. That was okay. So
I like
a
that.
bond is worth 2 electrons. So when I have 18 electrons left, I can add those on the outer shell. So like,
Pretty good.
but if I have 18 of these, if I was to make all of them gold, I have 20. I have to use 22 electrons. So I just make another bond, and that bond is worth 2. So I minus that bond.
actually
And I have 16 on the outer shell.
Okay, I need to.
So here, my arm on the sulfur.
Did you have it set up for the right number of valence electrons?
How many valence? 6.
How many valence electrons?
So if I go 2, 4, 6, 8, 10, 12,
Well, if we win then.
Do the sum of the
16,
If we win
18,
one, we just play it for fun.
20.
One, two,
And now,
As long as it's like you're in
Cool.
and if you
Like 6.
come up
So
first,
we only have 18.
yeah.
So you have to, so you, if you make another bond, if I bond
two and now we know.
no,
then I
this totally doesn't matter. This is just
minus 2 for my electron count.
I mean,
Because
you get a
the
trophy
bond is
for
worth
winning
2.
It's like,
Why do you minus 2 and not 4?
No, it's actually okay.
Because,
So we'll like did not want.
Yeah, each one of these.
well, I do like, it works. I got it right fifth.
The rest of your charges.
Sorry, I should have drawn it like this. Minus 2.
Maybe the metal.
I'm gonna be like,
These ones
for the junior teams.
So they're totally minus 16.
Yeah, it's whoever goes up.
These two.
Whoever goes up for the contest is gonna win.
This one, you're just way too excited and wanted to
I
start.
think, I don't know, there was something else when I saw class.
It looks weird, but it's actually.
Yeah, that was kind of fun. You guys are only so
They all have 6
I know, I'm gonna stop with that.
Kill Gato.
Julie? And, go through. Looking good, I think that's good. That seems good. We have to double check that. But actually, on either side, yep, that looks good, 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 good. Drawn twice. Good, 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 good. Oh no, terrible. There's something critically wrong with this. Yes?
Chlorine L-complex.
Yeah, so this isn't chlorine, this is carbon lithium that's missing the I. And what's that one? Yeah, you can put anything you want in front of it because they don't know it. So it's a quibble, but lowercase and uppercase actually matters in chemistry. I know it doesn't matter in much other places, so watch out for that. This, I think, has the wrong number of electrons. Oxygen is 6. 3 times 6 is 18. 2, 4, 6, 8, 10, 12, 14, 16. However, oh, yeah. Because O3, sorry, I counted it wrong. How many valence electrons does oxygen have? 6. What's 3 times 6? 18. Led me down the garden path. This is 2, 4, 6, 8, 10, 12, 14, 16. We're missing 2 electrons.
Can you just have a line?
Like that?
No. A little bit up.
A little bit up? There.
No. In the middle.
In the middle.
Ha ha, very humorous.
In the middle, like there?
That's what we're working on, but now you got your feelings. Put a line through your 2 dots.
Yeah, I know. But if I put, is that where you want the line?
No, at the bottom of.
Like bottom?
Yes.
Okay. Yeah, that works. However, is any of them now unhappy?
2, 4, 6, 7.
Bottom one's unhappy. What can we do with those electrons to make it happy? You're on the right track.
So why
Take.
so why they need an electron? Is mean to charge this chain.
It's now got the right number of electrons, so that's good. Yeah.
So
Yeah.
overall, we've established
No, good.
24 electrons. Like, they all have to be bonded at least.
When you have,
So 2, 4, 6.
if someone's unhappy,
We have
With-
18 electrons, and we have to make each.
I got everybody? If someone's unhappy and it has multiple bonds, just get rid of one of the multiple bonds. Move the electrons to a lone pair. Looking good, looking good. Yep, looking good, looking good. This one, here, 3 times 6 equals 18. How many we have here? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We have too many electrons. So I'm going to have to take away 2. Now,
Yeah, you slap a line on it.
yeah, slap a line from something else. So we got 2 electrons there. This one's happy. When you add a double bond, you take it from the one that's happy because it will still have it. It's just choosing to share. You don't take it from the one that doesn't have it. You wouldn't move them here. If you're down in your bowl of food and you have more than enough food, then you share with the person who doesn't have enough food in their bowl. So you look for the number of electrons. You see the one that has lots and the one that has little. That's the one who shares. Good, 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 good. Thought that was a squiggly line. This went too far. Nope. 2, 4, 6, 8, 10, 12, 14, 16, 18. Once again, it has the right number of electrons.
You're remove one of the lines and slap it on this one.
Yeah, remove one of the lines, slap it on the side, and now that oxygen's happy again. And And because you're using a mix of lines and dots there, it's going to make it consistent. Overall, pretty good. That's really good. Your quiz next week.
Wait, I thought it's today.
Yeah, you have a quiz today too. But your quiz next week will include. Your quiz next week will include a Lewis diagram of one or two of any of the compounds I've shown you. Now, I may do something fancy, like I'll take chlorine out and maybe put fluorine in there. How many valence electrons does chlorine have? 7. How many does fluorine have? 7. So it's the same compound. So I may change some of the elements so that it looks maybe a little different, but I will give you something that you have seen before. So if you can do all of these, you will be able to do the quiz. And I'll very quickly just draw the final answers so that if you need to go back to the live stream, you can. So we have them here because you did excellent work on the board. But if you wanted to go back, and what was the last one? SO3. Oops. Okay. That is the end of that. We're going to get a little bit of a start before we do the quiz on reactions. I have a whole series of demos set up. Unfortunately, the fume hoods are still being, we have to have final okay that I'm allowed to use them. So I probably can't do all the demos. I'm going to see 1, 2, 3, 4, 5, 6. Take that down. I am going to see if I can do at least one of them. Because it's kind of sad if we start reactions and we don't see any reactions. Like, that's silly.
Reactions are fun to do. They're like not fun to talk about.
Gummy bears. Okay, I swear, next day.
What you would do for this is put that 2, put that. Okay,
calm down.
That's butter.
So, Dylan, we'll get to there. No, so, apologies. I still don't have confirmation I can use the proper lab yet. Hopefully by next day. So I'll have a series of demos for next day. So we might as well get started so that you'll see the chemical change next day. But you've seen chemical changes already in a variety of different places. How do we know it's a chemical change as opposed to a physical change?
Use substances.
Riley?
Something new.
Something new is made? And how do we know something new is made? How do we know it's new? Yeah?
If you can't separate it,
If you get a
reverse it.
you difficult to reverse is one of the clues. Now, that being said, these are all clues. They're not facts. There are plenty of chemical changes that are easy to reverse. And there's a lot of physical changes that are hard to reverse. If I took all of your notes and I put it through a paper shredder, is that a physical change or a chemical change? Physical change. Would it be easy for you to reverse that? No. And if I mixed it with water and I pulped it into like paper pulp, but all the ink and paper is still there, would that be easy to reverse? No. So that would be very difficult. So some physical changes can be. So these are just clues. If you have enough of them, then you go, oh, it's probably a chemical change. But there's exceptions to all of them. Your hand is up.
I was just going to say that if it was new properties.
New properties. If you take chlorine gas and run it over sodium metal, you will get a fairly explosive reaction and a white crystalline solid made of both sodium and chlorine. And then you will take some of it and you will put it on your fried potatoes. And it will neither explode nor be poisonous. Sodium chloride has completely different properties because it's undergone a chemical change. What are the things that are breaking and forming in the chemical change? Yeah, bonds. Sometimes chemical, sometimes James. And we've already said new. So we've got some clues. It's difficult to reverse. Pardon? Bonds. New old bonds broken, new bonds formed.
We see what happens if you try to start that.
Yeah, those are the
Bonds?
Go on, right.
Yeah.
Yeah, absolutely. There is no doubt in my mind.
How?
What? Definitely was no.
No,
Yeah.
it knows things.
Is it just going to take you to remember how you wrote it was in the first place?
No, no,
You're fine.
not at all. That has nothing to do with it.
I'll just you.
And, hold it.
Chemical? Is that an E or a O?
What?
My fault.
What are you talking about?
My fault, dude.
See?
My fault.
It's beautiful. Difficult to reverse. What are some other clues? Yes. Changing color. Can anybody think of a chemical reaction where it changes in color? Baking. Cooking is an art, but baking is a science. If you get those ratios wrong, it is not going to come out right. Whereas if you're cooking on the stovetop, it's like, add some salt, add some spices, we'll mix it around. It's a real art. But if you mix something together carefully, you put it in at a certain temperature in an oven, you are making a chemical experiment, and you need to have the right procedure and skill to do that. Yep.
I would say new substrate form on top of liquid.
Ooh, new substrate on top of liquid. So, do you mean a solid?
Yes.
Yeah. New solid in a liquid. Do you have an example?
No.
Can anybody think of an example of a new solid appearing in a liquid? Yeah.
Ice.
Ice. Haha, is that a chemical or physical change?
Physical.
Physical. So there are exceptions to every single one, and that's one of them. So you have to be very sure that you're not having a phase change.
What about like that oobleck stuff?
Ooh, yeah, when you are literally mixing chemicals and making something else. They're actually making a polymer and then they fall out.
Can we make
Um,
like,
Pardon, we can't make blue black.
Wow, that looks so.
That's like a grade 3 lab.
I wanna make
What?
Yeah, yeah, we're not gonna make blue black.
I can't lie, that sounds way cooler than all that.
I'll see what we can do.
Yeah, we should.
Any other clues? Yep,
odor?
odor. I had a lab in university, a third year organic synthesis lab, and we were supposed to not only synthesize something, we were then supposed to run analysis on it and figure out what it was. And I was very lucky because my chief clue was that when I made it, it smelled like cinnamon. So all I had to do was go like, oh my God, and I just looked up a ton of chemicals that started with cinema, and it turned out to be cinnamaldehyde, which is one of the primary components in cinnamon. So it was very easy for me to figure out the structure. Yes, Jojo.
Then, so maybe the feeling is different?
Yeah. Change in texture. You have something that was smooth before, now it's gritty. Yep.
Exothermic reaction.
What does that mean? That's a label. That's not what you observe.
Release of heat.
Release of heat.
Or endothermic.
Release energy. And what do you observe when you release energy? We observe heat. What else could you observe? Light, sound, electricity. So there's a lot of ways to release energy, and any one of those would imply. Now, you can release energy. What else could it do? Absorb energy.
Did you try to spell texture but spelled it wrong?
I never spell anything wrong. Absorb energy.
Not an E,
Forgot to be on texture.
Can we see
Gets.
if we spell check it?
Sure.
It's like,
It's only
Fine. Whoa. Where's texture?
underneath smell.
Change in texture.
Finally seen it.
You can choose.
But it recognized my writing.
Dude,
Yeah,
spelling
yeah.
mistakes aren't good.
Yeah, they are. It's fantastic. They're fantastic. Okay, put everything away. You may keep out your own periodic table.
Are we doing a test now?
We're doing the quiz now.
Let's go.
Now, I want you to spread out, move your desks or change desks.
Test now?
Or one of those.
You cannot